Hi everyone, this is the second video of the series, Why Do Complex Ions Show Color? And in our first video, we looked at the various definitions associated with complex ions, what dative covalent bonding means, what transition metals actually are, so on and so forth. Well, in this video, we're going to specifically dive into why complex ions form color and why they show color. Last time we defined transition metals as metals when in ion form have partially filled d orbitals. And that is important because when we undergo the whole process of a central transition metal ion becoming a complex ion, as we've mentioned earlier, the transition metal ion will essentially form what we call dative covalent bondings with ligands, which are essentially molecules or ions, which in this context have a lone pair of electrons, and these lone pair of electrons will essentially kind of be offered by the ligand in this dative covalent bonding. And so what happens is the ligand's lone pair will essentially kind of, when the ligand in the transition metal ion forms the dative covalent bond, the lone pair of electrons of the ligand will essentially be located right here, and it's going to kind of push the transition metal ion's original electrons in its d orbital shell. And so what happens is when we engage in dative covalent bonding, which is basically a type of covalent bonding wherein the electrons that are shared in the bonding come from only one atom or one party, which is in this case the ligand. So what happens is when we engage in dative covalent bonding, the lone pair that is offered by the ligands will essentially slightly just push the original electrons in the d orbital of the transition metal ion. And so essentially, the electrons that were originally in the d orbital of the transition metal ion will essentially undergo a process of repulsion, which results in splitting of the d orbital. And it's going to split a division of 2 and 3. So this is going to be split in this formation. And remember that in each of these boxes, 2 electrons can go in. So when it splits into this position, as we shoot a beam of energy to the electrons of the d orbital, what's going to happen is electrons are going to get promoted from the lower split of the d orbital to the higher splitted d orbital. And so as an electron is promoted from the lower splitted d orbital to the higher splitted d orbital, what's going to happen is the metal ion is going to absorb a specific frequency. It's going to absorb a specific frequency of light. And what happens is, because a specific frequency of light is involved and absorbed in the process of promoting electrons from the lower d orbital to the higher d orbital, this specific frequency is going to lead to correlate to a specific color, and the color that we see from the transition metal ions formed the complex ions, the color that we're going to see in the complex ions is going to be the complementary color. Basically, we're seeing the color that is excluding the specific color of the specific frequency that's absorbed in promoting an electron. So we see the rest of the other colors, and we call these other colors the complementary color.